Hello students. In this second video in the three block problem friction problem series, we will start solving the problem with uh, F equal to 5 Newton. So in this problem, as we have seen earlier, there are three blocks A, B, C of 1 kg, 2 kg and 3 kg each. They are arranged on the top of each other. C block is resting on the flat surface. The static coefficient of frictions and the kinetic coefficient of frictions are available, are given for the three surfaces as you can see in the diagram, and the force F is getting applied on middle block B, F Newton. So now we are going to solve this problem, and the first case is that F is now 5. So F is 5 Newton, and we will assume G, which is the gravitational acceleration. Instead of 9.81, we will use 10 meter per second square, so that it is easy for calculations. So now the first point we have to understand is that we need to calculate the maximum. We have to understand this word maximum frictional resistance force between block C and uh, the flat surface. So we can see here the block C and the flat surface, that is this surface, where static coefficient is zero point 0.3 and dynamic is zero point 0.2 or kinetic is zero point 0.2. But as long as the block is not moving, we will be considering static coefficient of friction only. So the calculation goes like this: the frictional resistance force, which is the maximum, is given by the normal force which is currently acting between these two surfaces, and you can see that 3 kg, 2 kg and 1 kg all are acting uh, a downward force on this particular flat surface. So we will calculate that, saying that the total force is 1 plus 2 plus 3 into 10. So 336 into 10, 60 Newton is acting on the surface, and when you multiply by the static coefficient of friction zero point 0.3, you will get 18 Newton. So the maximum frictional resistance force between block C and the flat surface is 18 Newton. Similarly, we need to calculate the maximum frictional resistance force between block B and block C. So if you see block B and block C, on this surface, 2 plus 1, 3 kg is acting vertically downwards, and so that will be exerting this normal pressure on this surface. And when you calculate the frictional maximum frictional resistance force, we need to multiply that normal force with the static coefficient of friction, which is zero point 0.4. So the calculation goes like this: the total force which is working, normal force, is 1 plus 2, 3 into 10, 30 Newton, and when you multiply it by zero point 0.4, the static frictional coefficient, the maximum frictional resistance force between block B and block C is 12 Newton. So why we are calling it maximum? Because as long as the force F does not become higher than these maximum forces, the block will not move. So the moment it goes beyond 12, then only the movement will start. So to understand that, we will look at the free body diagram. So let us look at the free body diagram of block B. So as you can see on the top surface, the normal force because of the top block, which is 10 Newton, 1 into 10, as well as the it will be giving a reaction to that 10 Newton. So this is on the top surface. On the bottom surface between B and C, total 2 plus 1, 30 Newton will be acting downwards, and similarly we will getting a resisting force to balance it from the block C. So this is 30 Newton here, this is 10 Newton here, and they are getting balanced. That is why vertically the block will be stationary. When you look at the horizontal force, this is the applied 5 Newton force, and this is the resistance force, that is frictional resistance force at surface B or bottom surface of the B. So in this case, this will be because as long as this 5 Newton or this force F does not exceed the maximum force which will resist, which is 12 Newton, there will be no movement in the forward direction. So hence, because we are right now having 5 Newton, the frictional force will just balance it, and there will be no force in the horizontal direction also working on the body to move it, because this F 5 Newton will be balanced by the frictional force which will also equate it. So this will equation will be there. So horizontally also it is balanced, vertically also it is balanced. Hence there will be no movement. But we have to also look at, so between block B and block C there will be no movement. But we have to see whether this force is able to move the entire body of three blocks. So to check that, we have to look at the free body diagram for the entire block, considering it as one piece. Because B is not moving, A will not move. So we want to check whether C is moving. Because if the C is moving, then along with that B and A will be moving. But we have established that there is no relative motion between B and C. So if you look at this free body diagram, this is 60 Newton, because 3 plus 2 plus 1, 6 into 10, 60 Newton working on the surface, and surface will give its reaction of 60 Newton, which will balance it out. So there will be no vertical movement. Horizontally this is 5 Newton, and your maximum frictional resistance force at C on the surface at the bottom of C is, we have seen, it is 18 Newton. So because 5 Newton cannot overcome 18 Newton, there will not be any motion also between the surface and the body B. So there will be no motion between B and C, and there will be no motion between C and the surface. If 5 Newton would have overcome any of these two maximum forces, then only the relative motion will start and there will be acceleration. But in this case, because 5 Newton cannot overcome the maximum force, frictional force between B and C, neither it can overcome the maximum frictional force between C and the surface. Hence, there will be no movement, and hence there is no acceleration. So in this case, acceleration of A equal to acceleration of B equal to acceleration of C, which is 0. No movement at all. In the next video, we are going to see if, because see, this will continue between as long as the F does not exceed 12 Newton, because the minimum of the frictional resistance is 12 Newton. So as long as it is 12 Newton or less, there will be no movement. So now let us consider case 2, when it exceeds 12 Newton, say it becomes 12.5 Newton. So in my next video, I will take the case, the same problem with 12.5 Newton force working on the middle block, and we'll see what happens. You can also try meanwhile. You can wait for the next video, but you can also try this problem yourself. So let us meet in my next video in this series. Thank you.